2. My name is Abdul Gani Abdulmajid, a student of Mechanical Engineering UI 100 level. Now, we'll be talking about this, we'll be solving these KIRCHOFF questions. This case 1. Now, this is what we have inside our slide, something like this. Now, you need to check this now. We have how many loops here? We have 1 loop, 2 loops, and the 3rd loop. The first loop, 2nd loop, and the 3rd loop. The first loop is like this. Can you see? So the 2nd loop is like this, while the 3rd loop is like this. So that's what forms. So we have, since we are having 3 loops, 1, 2, 3, we will have 3 simultaneous equation. Please take note. 3 loops, 3 simultaneous equation. If you have 2 loops, we have 2 simultaneous equation. Please take note. Now, how will I do this now? You look at loop 1. This is loop 1, this is loop 2, and this is loop 3. You add all the current. I want to do loop rule now. Loop has to do with voltage. Loop has to do with what? Voltage. While junction has to do with current. So loop has to do with voltage. Now, I want to do voltage. You add all the current in that loop. Look at loop 1 now. How many current do I have? I have 3K and I have 10K. 3K and I have 10K. You add it together. 3K plus 10K. That's what? 13K. But please take note, before I continue, you will need to assign current to each of the loop. Look at loop 1. Where can I place this current? Better look up now. Loop 1 now. Look at this current. This current here is still the same thing as this one. It's still the same thing here, and it's still this one coming here. So this one is equals to this one, because it is the same current that is flowing like this, coming up and coming here. So this and this, they are the same. Now this one now, I can place the current of the first loop. I can place it here. For this 2nd loop, where can I place the current? If I place the current here, it will be as if I place it here, it will be as if this 2nd loop and this first loop, they are sharing this place. If I place it here, it will be as if I place the current here in this direction, it will be as if this 2nd loop and this 3rd loop, they are sharing this current, and that's bad. We want a current that will be what? That will be only for that loop. This one now is only for this loop. Unless it enters this place, that's when it is going to split. But for this one now, it is only for first loop. Where can I put the current for 2nd loop? Is it here, or here? I cannot put it here, because it will be sharing it with 3rd loop. I cannot put it here. It will be sharing it with what? First loop. But I will put it here. So I will call this one I2. Let's call this one capital letter I. Let's call this one I2. Where can I place the current for what? For this 3rd loop. Where can I place it? We have 1 here. Can I place it here, or here? I cannot place it here, because it will be as if this and this is sharing it. Can I place it here? No. This and this will be sharing it. So this is the only place I can place it. So let me call it what? I3. Now you add all the voltage, all the resistors we have in the first loop. The first loop, what are the resistors we have? This is first loop, like this. This is first loop. This is what I am doing. So we have 3K and we have 10K. 3K plus 10K, that's what? 13. This 13 is just the resistance. I'm doing voltage, so I will multiply it with current, because V equals to IR. I've calculated my total R, so I'll need to multiply it with the current. What's the current? Because I'm doing the what? I'm doing for loop 1 now. What's the current of loop 1? The current of loop 1 is capital letter I. So the answer is what? 13I. Now, you will not check that this 3K now, this 3K is sharing it with 2nd loop. So you subtract it, minus 3. Then this is just resistance. I will need to change it to voltage. 3. Then what's the current of the 2nd loop that is sharing something with loop 1? What's that current? The current is what? I2. So minus 3I2. Again, look at this 10K. This 10K is sharing something with loop 3. This is loop 1, loop 2, loop 3. This 10K is sharing it with loop 3. They are both sharing it. It's for the 2. So I will say minus, because they are sharing it, I will subtract it. So minus 10. That's 3rd loop, right? So what's the current of the 3rd loop? I3. Then equals to, you will not travel around the loop. How will I travel around the loop? If I move like this, I'm moving from negative to positive. If I'm moving, this is the convention for voltage. If I'm moving from negative to positive, the answer will be positive. But from positive to negative, it will be negative. So I'm moving here. How am I moving? From negative to positive, like this. I will come back here. I will come back where I started from. So from negative to positive, that's positive. So for loop 2 now, loop 2 now, loop 2, you add all the resistance together. What are the resistance? 3, 2 and 1. 3 plus 2, 5. 5 plus 1, 6. So that's what? 6. I'm doing for loop 2. What's the current for loop 2? I2. No, that's plus 6 I2. Why did I write it under I2? So that I want to form simultaneous equation. So I'm writing it under I2 so that they can be under each other. Now look at this loop 2 now. Loop 2 is sharing something with loop 1. What is it sharing? It is sharing 3k. This 3k will now be what? Minus 3. It's sharing it with 1, Abi. Minus 3i. Then this loop 2 again is sharing something with third loop. That's what? Minus I3. Do we get it? Equals to, this one does not have voltage at all, so equals to 0. For the loop 3 now, loop 3, you add all the resistance together. 10 plus 1, 11. 11 plus 5, that's what? 16. So you say plus 16 I3. Because I'm doing for loop 3, you use the current for 3, 16 I3. This loop 3 now is sharing something with 2. What is it sharing? 1. So that's minus I2. This loop 3 again is sharing something with 1. What is it sharing? 10. So that's what? Minus 10i. Then this one does not have voltage as well, equals to 0. So you solve this simultaneously.